So in this video I want to talk to you about all the ways, or at least many of the ways, that you can change colors of your plots and graphs in Plotly. Now we are here in R Studio and I'm going to show you the actual code as it's put together in an R Markdown file. Remember, this rendered file is available on RPubs, and this actual RMD file will be available on GitHub as well. So you can see the markup language at the top here, just to instruct this coding to HTML what to do. We see a title there, author, and the output is going to be HTML, and the table of contents set to true. So let's have a look at the libraries that we're going to use. I'm going to use a tibble as always. I prefer that over data frame. Just to print a data frame nicely to a web page, I'm going to use the DT library, of course Plotly, and then the RColorBrewer. Now, RColorBrewer is a website that you can visit, and then there is this wonderful package in R that can make use of those colors. As always, I do use some cascading style sheets just to color the heading 1, heading 2, and heading 3 levels. I have a logo that I always insert in these RPubs documents, and you can see there how I add that. Now remember, I am using the set working directory, get working directory function I'm using up here, and this RMD file and this PNG file live in exactly the same folder. So that by default then, as I mentioned, Plotly has some excellent colors and you can customize them extensively, and then if we add our RColorBrewer package, we can do even more. So first of all, let's create some data that we can work with. I'm going to just set the pseudo-random number generator. I'm going to seed that with an integer 1, 2, 3, just so that if we rerun this code, we get exactly the same random values back. I'm going to create a computer variable called cities, and that is going to have a sample space of these 1, 2, 3, 4, 5, 6, 7 cities, and as I quip there, spot the odd one out. Anyway, I want 200 of those at random, and replacement is true, so that when one is drawn, that name goes back into the hat to be able to redraw. So let's run all of our code. I'm going to run all the imports of my libraries there. And then if we go down, let's create these random values. Off we go, and we see on the right hand side under global environment, I see that I have 200 values in there. Now remember, if we use the table function on the cities, that is going to give me back, at least to the screen, this little table that just shows me the sample space values: Boston, Cape Town, LA, Miami, New York City, Seattle, and San Francisco, and the number, the count of those unique values amongst these 200. If I just use the names function on this table of cities, I'm just going to save as a string vector then the names, Boston, Cape Town, and let's store that in a computer variable called city.names, and you see I have my 1, 2, 3, 4, 5, 6, 7 cities there. And if I use the as.numeric function on this table of the cities, then I'm only going to save the numbers, the counts. So let's do that. And if I do have those, it makes it easier to create a bar chart. Now remember, bar chart just shows us these counts, so it's very good for a categorical variable. So let's create it there. And we see plot underscore ly. And I'm going to add to that a trace, and this trace type is a bar. Remember, all of this could have just gone into that function right there. This is another way to do it. On the x-axis is the city.names. Remember, those are just the 7 names. And the y-axis are those counts. I'm doing some layout by putting a title, x-axis, and a y-axis. On the x-axis, I want a list because I have both title and 0 line, both those keyword arguments. And something else that you'll see here, I use fig.cap as part of my R notation up here, and that just creates a nice little caption for my figure if I render that out to HTML. So there we go, and we see the default deep sky blue color. It looks fantastic. I can hover over those and see the counts. We can see LA there at 34, San Francisco also at 34. So let's just change away from this deep sky blue default by using RGB and RGBA. Now RGB stands for red, green and blue, and that is how your television works, how your computer screen works, those red, green and blue little dots on your screen, and each of those can take up a value from 0, that's absolutely black, to 255, which is maximum intensity, so 256 levels there. And if we push the red all the way up to 255 and keep the others dark, those pixels, you're going to see red. And then you get these mixtures in between. The A is for opacity. So I can also, if I use RGBA, add a fourth value. And that ranges from 0 to 1, and that has to do with a bit of transparency. So let's do that. It's exactly the same plot, but this time I'm going to use the marker keyword, and I'm going to pass a list to that because I want to use the color and the line keyword arguments as part of this marker keyword argument. So the color, I'm just going to use RGB, that's 195, 195, 195. So that's sort of a light grayish color, all the values being the same. There's not going to be a color cast, no color dominates. So that's just going to be on the spectrum of pitch black to white and gray levels in between. So this is going to be a lighter gray. The line, as part of the marker, tells Plotly what you want the border of whatever you're trying to plot to be. So that color I'm going to use RGB 20, 20, 20. That's very low intensity, so that's going to appear very dark. And I want a pixel width for this border of 2. Everything else stays the same. Let's have a look at that. And now we can see our lighter gray and our very dark gray, almost black border to these. So very easy to change the colors. This might be more appropriate if you're going to submit it to a journal who wants monochrome images. So let's just add a bit of opacity to that. So on the color here, I'm going to use this 255 in the red channel, nothing in green and nothing in blue, but I used RGBA, so I can put this fourth value, 0.6, that's the opacity. 0 meaning that they from 0 to 1, as I said, and that is from being fully transparent at 0 to fully opaque at 1. So let's do a 0.6 there, and you're going to see the red's going to be a bit see-through. And there we go. So you can see those lines come through as far as the red is concerned. Now I can individualize each of these bars. I can give them each a value. So my marker here again, I'm going to pass a list of values. The color is what I'm after in this instance, and I need to pass values for all 7 of them. So you can see 2 of them are a bit different, and you've got to do it in the order that they did appear here. That vector of names that you created initially, you have to follow that order. So let's have a look at this. And there you go. See, there's no border. The color was the only keyword argument. And here we can see the transparency at 0.7 for all of them, but you can see these 2, the LA and the San Francisco, they were the highest, they had the highest count, so we colored them in red. So you can really just individualize those colors. Instead of using RGB and RGBA, we can actually use a list of named colors. And if you go to this website of the World Wide Web organization, you can see a list of the color names that you can use, and you can see we said here silver, silver, red, silver, 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 red. And then the opacity, remember this one didn't have any opacity when we right at the beginning. Up there, now I'm going to add some opacity, and that opacity has to go on its own, and I'm just repeating 0.77 times, so I have this vector of 0.7, 0.7, 0.7, etc. So let's have a look at that. There we go. It looks exactly the same. Those values I used were for silver and red, and that's another way that we can do this by just using these names of the colors. Another way to go about it is just to use hex colors, hexadecimal color values, also HSL, hue, saturation and lightness, and HSV color sets that you can use. So here I'm using the hexadecimal color set, and you see there I pass it as this vector of these strings, and those are the values for red, green and blue, C0, 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 and then FF00. That FF is maximum. It's 2 to the power 4 is 16, so that's the maximum value there. And if we print this out, again, notice the opacity there, I'm just repeating 0.77 times. Again, exactly the same thing that we're going to get back. Now, we've also got some inbuilt color palettes that we can use. First of all, though, let's create a tibble, and it's just going to hold all of these values for us. So there's my df is my computer variable. It passes a tibble, city, and sale. So city is going to hold all my cities, the 200 that we created before. And then I'm just going to create another set of values, the length being the number of cities. So those are equal. I'm going to round it to 1 digit, and a mean of 100 and a standard deviation of 10. And then the data table function from the DT package. And that's going to print it to the screen very nicely here. You can see you can run through all of those. You can even go for ascending and descending order. You can show how many entries you want to see at one time. Very nice, the DT package. So here we go. We're going to add this trace. The data is df. On the y-axis, we want sale, and on color by city. Remember, that has nothing to do with color. If you wanted colors, that would be with an S. So let's just have a look at this box plot. And that is just going to give us these cities, and then the sales on the y-axis as we asked, and that sale is now going to just be individualized for each of the cities. And that's the default we use there, but let's use one of the color sets. You see the color sets, for instance, they have set 1, set 2, set 3, pastel 1, 2, and paired, and dark 2, and accent. And so those are the qualitative palettes. You get many sequential, that's this light to dark palettes, and you even get these dark to light to dark palettes as well. And examples of those would be dark 2 and BRBG. So let's just have a look at 2 of these. Here's the dark 2. So let's have a look at that. And indeed, you'll see the very dark colors there. And we're plotting out exactly the same thing, but by a certain palette. And let's have a look at this brown, green, and beige kind of color. So you see it goes from dark to light to dark. So if you go to the ColorBrewer website, you can certainly have a look and also look at things like color blindness, etc. A lot for you to read, and I've put a little of that from their webpage, our ColorBrewer package at least, in here for you. You can also go to colorbrewer2.org and you can read more about these. So let's use that. And one of the palettes is the paired palette. So the way that we're going to do that is say colors equals brewer.pal, pal for palette. The number that I want is the length of the names of the tables of the cities. Remember there were 7, so that's going to give me 7 colors back, just using the length. If I knew it was 7, I could just have said brewer.pal and then 7, comma. What I want is the paired palette. So let's have a look at what that looks like. And there you go, the paired palette. That looks rather nice. And let's use something else. Let's just have a look at this. Now the thing is that many of these packages have between 8 and 12 possible colors, but you might have a need for more than just those 12. And you can certainly do that with our ColorBrewer package. And we're going to use the color ramp palette function as a keyword argument. So this is how we would go about it. First of all, I'm just creating the sequence of values from -2 to 2 in steps of 0.1. And on the y-axis, I'm taking the sign of each of these values. So I'm going to create this scatter plot. X is going to have my X values, that sequence. Y is going to have the sign values. Mode is markers. So it's a scatter plot. And the marker is a list, size equals 10. And the color then is this color ramp palette. Inside of that we have brewer.pal, and we're asking for 10 there. Spectral is what we want, and we want 41 of these colors, please. 41 colors. So let's have a look at that and see how that comes out. Beautiful. There we see our sine curve, and we can see all these colors from red to blue and the 41 shades that we can see there. Absolutely fantastic. So that's in short how to manage colors inside of Plotly. There's really the sky's the limit. You needn't stick to deep sky blue. You can choose whatever you like, and there are many ways to go about this.